Good morning, I'm Kirsten Baumgart Turner, and this is Sustainable Hawaii at ThinkTech.com, streaming live educational and civic engagement on the internet and on Oceanic Channel 16. My guest today is Mr. Henk Rogers, a highly successful serial entrepreneur and global citizen who's made Hawaii his family's home since 1996. Raised in Holland until age 11, Mr. Rogers attended New York City's Stuyvesant High School that specialized in mathematics, science, and technology. Later, he came here to study computer science at the University of Hawaii. In the 1970s, Henk moved to Japan to develop video game software. In the following 2 decades, he became renowned as a global leader in the gaming industry. Henk revolutionized the industry when he brought the now legendary Tetris game to the United States and world markets. In 1996, Henk moved back to Hawaii, where he founded several more gaming software development companies. But happily for our viewers who are interested in sustainability in Hawaii, Mr. Rogers turned his attention and technology skills to solving Hawaii's high-cost, oil-based energy problems. In 2005, he created the Blue Planet Foundation. And we're showing their website on the screen. It's become the frontline organization in the fight for locally produced renewable energy in Hawaii. Henk also founded Blue Planet Research to develop off-grid energy solutions, including hydrogen production and battery storage. Just last month, he co-founded a new company, Blue Planet Energy Systems. This provides an important energy storage solution for homes and businesses running on intermittent renewable energy sources. Henk, before we talk about all of those very important developments that our audience is tuned in to, I want to have them share in the experience you just had on the Hokulea. Henk returned recently from a jaunt from Darwin, right, to Bali. And will you tell us a little bit about it and how it affected you?
Yeah, so it's my second time to be on the Hokulea. And every time is different and magical. So this was the first time that Hokulea left the Pacific Ocean on its 3-year voyage around the world to bring peace and ocean issue awareness to the rest of the planet. And I asked Nainoa if I could be on this leg because I have Indonesian roots. And since we're going to Indonesia, I would really have like to be one of the ones who arrived on Bali, and it was just a magical experience. Being on the Hokulea is amazing. It's really, really hard work, but it's really, really rewarding.
How did it feel being back in Indonesia and coming aboard the Hokulea? And when was the last time you'd been there?
Well, okay, so I've been to Bali several times before, but landing on the shore, the way it works is you get off the canoe, the va'a, and you stand in the water and you ask the people for permission to land, and this is in the form of a Hawaiian chant. And so we chant and we sing and we are given permission to land, and that in itself, that little ceremony is so magical. It goes back, hundreds, if not thousands of years, where the Polynesians traveled from island to island, and each time, as a how can I say, showing of friendship, they would ask for permission. They wouldn't just land. And that's how the brotherhood of people, how can I say, is expressed.
Well, wouldn't this be a good example for our diplomats today in our crazy world if they treated each other with the same deference?
I think diplomats are not allowed to get their feet wet. Although they should, and that would be a sign of humility.
Well, Henk, another thing I've been wondering about is you were in this rapid-paced world in Japan of software development for gaming, and then you made an abrupt turn and came to Hawaii. Or was it so abrupt?
Well, it wasn't quite so abrupt. I'd been in the business for, I started in 83, left in 95, so 12 years. And I noticed that the internet was happening in the US and it wasn't happening in Japan. NTT in Japan, in its infinite wisdom, charged prices so high that ordinary people couldn't have access to the internet.
And NTT is?
Nippon. It's the big telephone company in Japan that had the monopoly on communications at the time. So actually I moved to San Francisco, and I lived in San Francisco for 7 years, trying to make money in the dot-com bubble era, and I never could quite figure it out. And so finally, when mobile phones came out that could actually play games, that was my big opportunity to come back to Hawaii. So it was 2002 that I came back and started Blue Lava Wireless.
And why was it the mobile gaming industry that allowed you to make that transition?
Well, so first of all, mobile gaming, at that time, the handset, the phone, only allowed you to have like 64K. And that goes back to the early days of computer gaming, like when I first made my first game, which is also 64K. And I basically had zero experience. So what I didn't need was a bunch of people who know how to make gigantic games and try to teach them how to make tiny games. What I really wanted was people who had no idea how to make a game, and their first game would be in 64K. That's a lot easier to do. So we hired students straight out of UH that had never made games before, and there were some veterans in there. But basically at the end of the day, when 3 years later we had 50 people working in the company, and there were only 2 people from the mainland in that company.
So one of the things that all of us have admired is your ability to grasp this kind of right-brained approach to solving complex problems that those of us left-brain people have been working on for years. And I noticed that you engage a lot of you look at people's skills and opportunities and then apply them to a problem, not necessarily in the same approach that many people would do. Why do you think, what gives you that particular perspective?
Yeah, so I was a little rebellious when I was younger. Maybe I'm still a little rebellious. And so I didn't follow one path all the way. I followed many paths. And so I think of myself as sort of a jack of all trades, or a handyman. And so I know a little bit. I know how to do plumbing, electrical work. I know how to do woodworking. I know how to do a little bit of everything, enough for me to be able to talk to all of those people. So, I know programming. I didn't know business. I know business now. And so there's a whole spectrum of things that enabled me to connect to people on the art side and on the tech side. And frankly speaking, I'm working on my art side myself now.
Well, maybe if we look at a few of these photos of the Hokulea, we can see how you brought all those skills to bringing it across the Pacific. These are your photos, right?
This is a picture of Hokulea when it was still burst in Darwin. Darwin, Australia is a kind of a unique place. They have beautiful oceans, but nobody goes in them because they have something called a salty, which is a saltwater crocodile. Ooh. And so here's the Hokulea birth the night before we departed for Bali. And this is us getting ready in the morning. You can see the jerry cans of water. We're making sure that everything is ship-shape, because we don't want anything to go wrong. In this case, we're putting down the lines so that somebody doesn't trip and get pulled overboard, for example. So these are all things that we're very, very careful about on the Hokulea.
What are some of the sustainability practices?
Well, we don't use any electricity except for a little bit just to communicate with the satellite. If there's an emergency, then we have to communicate and find, like if there's a man overboard, then we break the rules. The rules are that we don't have any communication with the outside world, and we navigate by the stars, the sun, the moon, the wind, and the waves. This picture was taken at Ashford Reef, and it's an atoll about 15 miles across, and it's like a big sandbars circle with coral on the inside and on the outside. And so this is the Hokulea parked next to the coral.
I think we have a picture of the sandbar as well.
The sandbar is like amazing. I mean, this is like so pristine and so beautiful. It's just an incredible, and nobody lives there, of course. There were some border patrol in a boat, in a ship, but we were on the island. We're the only ones on this particular island.
What were some of the climate change evidence that you saw during your trip?
So as we were going from Darwin to Ashford Reef, we saw many sea snakes. And in fact, when I took a picture of a sea snake and it became a big hit on Hokulea.com. Everybody looked at that sea snake picture. Well, when we got to Ashford Reef, we were told by the border people that were there that Ashford Reef actually historically was like a mecca for sea snakes, with 40 different species identified that lived on the reef. Now, sea snake, yes, they're poisonous, but you would really have to like take one of their heads and squeeze your finger into its mouth to be able to get a poison effect, and then you might die from that. But so they're harmless basically to people. Today, when we were there, 0 sea snakes.
Wow.
So we have no idea where they went, if they went anywhere. If Ashford Reef was one of their breeding grounds, it isn't a breeding ground because they haven't seen a sea snake there in like 5 years or 7 years, something like that. And so this is an evidence that something drastically has changed. It certainly isn't because there's any kind of local pollution, because there's no people there.
Right.
And so we don't know. Nobody knows why they went away. And this is just an example of one place where there's some kind of basic change that nobody's, all of a sudden it's just happened. And global warming and ocean acidification will keep on making those kinds of changes.
Right.
And we just have no idea what we're doing.
Were there discussions in Bali and in Australia and New Zealand, I'm sorry, also about sea level rise? And did you have evidence of that in the trip?
Sea level rise, of course, you have evidence of it, but it's mostly where people are living that people complain about sea level rise. And if they're living on an island which doesn't have a lot of water, where the lens is very shallow, then sea level rise will take their fresh water and turn it brackish because the seawater is invading. So it's really sad that a lot of islands are going to become uninhabitable, and we'll have refugees as a result. I think we have some in Hawaii now.
Absolutely, yeah. What are some of the examples of sustainability that you saw in your travel?
Well, so Bali is just at the very beginning of their sustainability. We saw a lot of evidence of unsustainability, and it kind of hurt. There's a lot of plastic garbage in the harbor and in the streams and so on, and so the culture hasn't quite caught up to other places where we are very concerned about, our environment. It's just a matter of time, education. We all visited the Green School, and the Green School is a sustainability school, and it's an amazing place.
Actually, we have a couple pictures of the Green School, if we could put those up.
While you're working on it. So the Green School itself is made all the buildings are made out of bamboo. And there isn't a square corner anywhere. It's just all curvilinear, and it's all made out of bamboo. The idea is that once they're done with the Green School, it can all be composted and the whole place can be returned to what it was like before. And that's the example that they want to give to all the students. Between the buildings, they grow vegetables and pigs and chickens and whatever, and the kids get their hands dirty. They compost everything. Even the toilets when you go to the toilet, there's a separate toilet for number 1 and number 2, because number 2 goes into the compost. Number 1 gets used in something else on the vegetables. So, these are kind of simple things that they do. They collect all the plastic, even the plastic from the river, and they collect all the plastic and make them into pallets, plastic pallets. Now, when you have a pallet, the forklift pallet,
right?
When you put something on a pallet, you take it to another place, those pallets are thrown away. There's no way to bring them back.
Right.
But these plastic pallets stack like egg cartons. And so you can stack them and make a big stack and take them back and use them again. And that's a way for us to take our plastic and use it for something rather than burying it in a landfill or letting it go into the ocean, which is the worst thing that
Well, it's
that
good to
happens
hear
plastic.
because you see so many different opportunities for reuse of the wood pallets nowadays, even into furniture, but I hadn't heard of the pallet reuse with plastics.
Yeah.
That's great. Well, we're going to take a little break, and when we come back, I want to talk a little bit about your work at home. I think our viewers are going to be very excited to hear about all of the technology improvements you've been working on.
All right.
We'll be
great.
right back.
Thank you.
And I am the host of Business in Hawaii. Business in Hawaii is a show where we invite guests to come on and explain the secrets of their success for having a successful business in Hawaii. Contrary to popular belief, having a successful business in Hawaii is possible, and there are many examples of that. So please tune in on Thursdays at 2 o'clock, and you can catch us live on livestream.com for our Business in Hawaii show. You can also get the archives on hawaiitechhawaii.com, and we're also on YouTube and also on Oleo and OC16 occasionally. So please join us, find out the secrets of success, how to have a successful business, and I hope to see you on Thursdays.
We're back with Henk Rogers, a serial entrepreneur and a tremendous philanthropist for Hawaii for the last 20 years. Hi, Henk, I think our viewers would like to know more about your research, Blue Planet research, and what you've been doing at your ranch, because you've been tinkering with a lot of new technology developments that not everyone are aware of.
Yeah, so it's funny. It starts like I need a workshop because I'm a tinkerer myself. And so I talked to my architect, Paul, and I said, I need a workshop. And we discussed it, and he made me a world-class workshop. There are 4 bays that are actual workshop and 3 bays that are like little studios for scientists and engineers to stay while they're working on projects.
Oh.
We have 360 panels on the roof. That's 85 kilowatts of peak power. We take that power, which is way more than we need at the ranch, and we study energy storage, or what do you do with extra energy when you're off the grid. So we are off the grid, which means we're not connected to HELCO, what an appropriate name for that company.
Hawaiian Electric Company.
Hawaii Electric Light
Company on the Big Island, that's right.
On the Big Island, HELCO. So when you're disconnected from the grid, you have to be able to have enough energy or store enough electricity for a bad day, so that it could be cloudy all day and you still make enough. So on a good day, like on a sunny day, our batteries are completely full by like 9:30 in the morning, and so we have the rest of the day of energy that we can play with. So what do we do with the rest of the energy? We're playing with making hydrogen. And hydrogen cars are coming, the hydrogen economy is coming. The problem with Hawaii, we spend $5 billion a year on oil. And 30% of that goes to jet fuel. And you could say, well, we don't know anything about jet fuel, so that's somebody else's problem, which it's not, it's our problem. But then the next 30% is transportation. And it's gasoline and diesel. And that gasoline and diesel, those are all cars and buses. That can be replaced with hydrogen.
And I think we have a picture of your hydrogen electrolyzer as well that you have at your ranch. Right. So
I don't know if you do or not.
Love to see that up there.
So the electrolyzer enables us to make hydrogen with the excess energy. So if you were to make a facility just to make hydrogen using renewable energy, hydrogen would be pretty expensive. But we're throwing energy away every day. And if everybody would just take the energy that they're throwing away on a sunny day and turn it into hydrogen, they would have enough fuel to power all of their cars, their cooking. We're learning how to cook with hydrogen.
Can you explain just briefly how it works?
So hydrogen, when you burn hydrogen in a flame, the byproduct is not carbon something, it's not carbon dioxide, it's hydrogen dioxide, which is water. And so when you touch the flame, when you put your hand above the flame, it's actually damp, it's producing steam. And so the byproduct of a hydrogen car is water vapor or drops of water. And so this is like the best solution.
So your excess solar energy that you're creating with your panels, you're using to burn the hydrogen?
Well, okay, so the excess, no. So the excess, we make hydrogen using an electrolyzer. And this is high school chemistry. You've got the plus on one side and the minus on the other side. You turn the electricity on and the bubbles come off the plus and the minus. On the plus, it's oxygen, and on the minus, it's hydrogen. And
Got it.
basically what we do is we collect those two gases and we put them in canisters or tanks. And actually, we store the hydrogen. The oxygen is really dangerous because it makes anything burn. And so we vent the oxygen into the atmosphere right away. If we had fish, we would feed the fish with the oxygen. That would be a good thing, like if we were doing aquaponics. And we are thinking about ways to use the oxygen.
So there's a way to use all of the resources that go into the hydrogen production in a
Yes.
closed loop system for sustainable outcomes at your ranch.
I wouldn't go so far as to call it closed loop, because we take the hydrogen from the from the water, and then we release into the atmosphere. But it becomes water again. So.
So in that way,
But there's no pollution
it's
involved.
Yes, it's not creating pollution.
There's no pollution involved unless you consider water vapor pollution. And there's a lot of worse thing that we put into the atmosphere besides water vapor. So hydrogen can be used in automobiles or transportation in two different ways. You can take an existing internal combustion engine. That's an engine that burns gasoline or diesel, and you can convert that engine so that it burns hydrogen instead. You have to change the gas tank and put a hydrogen tank in there. You've got to pressurize everything, but it's something that can be done in 8 hours. So that's one way. But a much more efficient way is to use a fuel cell. And a fuel cell is similar to an electrolyzer. It's backwards. It takes the oxygen and the hydrogen and puts them together, and it generates electricity when it combines the two. That's how the Toyota's new Mirai car runs. And it's twice as efficient as using it in an internal combustion engine. So if you're going to make a new car, you use a fuel cell. If you want to convert old cars, you're going to convert.
Now, I understand one of the obstacles to hydrogen car development, or also hydrogen for electricity development, is that it's a relatively low density volumetrically gas. So it's very difficult to package it and distribute it safely. What are some of the things we need to be working on to solve that?
If you want to just contain hydrogen as hydrogen, then yes, you have to pressurize it and try to squeeze it into a small space. Or in the case of the space shuttle, even cool it down to the point where it becomes a liquid, which requires a huge amount of energy. But there are lots of other ways of storing hydrogen besides just compressing it or cooling it. You can turn it into ammonia by adding nitrogen, and so it's a way of storing hydrogen that takes a lot less space and doesn't
less
require
energy as well for the
and doesn't
conversion.
require any pressurization. There are certain I don't know the chemical name, I forget, but there are certain kinds of tank that you can have where the hydrogen actually gets sucked into the material, and it stores way more than you could possibly squeeze, get if you were squeezing it.
So are these technologies that you're testing at your lab?
Little by little, we're testing all of, we're going down the line. We're working on the conversion of cars to be able to use hydrogen now. And
I understand you have a hydrogen fueling station at your
We have a hydrogen fuel, but it's funny because we started making hydrogen, and the Department of Energy found out that we're making hydrogen. So like, wow, you guys are making hydrogen. I said, yeah, yes, we are. And so they said, well, we have a bunch of hydrogen stuff. Would you like some? And we said, sure. So the only thing that we have now that runs on hydrogen are forklifts. So forklifts with fuel cells. The problem with a forklift is you cannot have an internal combustion engine in a vehicle that operates inside of a warehouse.
Right.
People would fall asleep or die.
Right.
And so they have to be electric. And the problem with electric forklift, regular battery-operated electric forklift, is that it takes like 8 hours to charge the battery. And then you have to wait another 8 hours while the battery cools down to the point where you can actually drive it around. So you're only getting a third of the time on the forklift. Whereas if you replace the battery with a fuel cell and hydrogen tank, you can, like, at the end of a duty cycle of 8 hours, you can just gas it up with hydrogen, and you've got another 8 hours.
So actually, you have a hydrogen electric vehicle.
We do.
Yeah.
We do.
And so that maybe that is a paradigm shift that we all need to make, in that electric vehicles aren't just a possibility or obviously existing. I drive one myself for plugging in and receiving electricity that is produced from imported fossil fuels. But we could have hydrogen electric vehicles that are not based on fossil fuel electricity production.
Well, my electric car, and I drive a Tesla, is I only charge it at home when it's daytime.
Mm-hmm.
And so it's all PV, so my car doesn't use any fossil fuel to get its electricity.
And then do you use your car as energy storage for later use in the hours when you don't have the sun?
Yeah, so the Tesla will take your energy but will not give it back. So it's not built to do that at this point.
Is this something, though, that you're working on? Because a lot of discussion out there is about how to use electric vehicles for storage, energy storage.
Yeah, we're not exactly working on that because it's not clear to me that I'd like to have my car be my storage device. Mm-hmm. So if I get up in the morning, I've got to go to work, and my car has drained, my house has drained my car battery.
Right.
That's not going to work for me.
So you're thinking this may not be the best solution for people to pursue?
I think if when you're at the office and your car is parked, I think the electric company should use your car as a place to put electricity. Mm-hmm. During the day, we need places to store the electricity, and if there are batteries anywhere, we should be filling those batteries.
So what would it take for that to happen, for the electric company to start using our cars as a storage instead of our cars drawing electricity from the few electric pumps that are out there right now?
I think the electric company needs to start to have some skin in the transportation game. They need to start thinking about cars and buses. And right now they're happy that we're using their electricity to charge our electric cars, but there's no conversation about, how can they work together. I was just talking to somebody this morning on the phone, actually in Holland. The way it works in Europe, in Holland, in Belgium specifically, is every 15 minutes, the electric company publishes on its website the price of electricity. So it fluctuates, it switches every 15 minutes. What that means is that, in a couple of hours, the electric price will go up or down. And so what you can do as a businessman is you can build a battery bank, and you can download electricity. I'm such a computer geek. You can download electricity when it's cheap, and then upload it when it's expensive, and then so you're making money. And as a result, the grid now has storage to move renewables from times when there's too much of it and the price is low to times when there's not enough of it. So it's load shifting.
What will it take us to get there, to have that dialogue and that interaction with the electric company, to be able to connect the electric vehicle manufacturers, the charging station manufacturers, and the utility to begin to talk? We
need a smart grid. The electric company needs to know when something is being charged and when it's not, and so they can turn it on and off. I've been listening to the news, and the electric demand, because of the last few days of hot and humid, has been overwhelming. And so if there was a smart grid, then the smart grid could say, please don't heat your hot water at this time, for example, and it could switch off the hot water heaters.
Right.
When there's lots of extra energy in the daytime, that's when you want to heat the water. Those kind of things need to happen so that we can use electricity when we have a lot of it and not use it when there's not enough of it.
Terrific. Well, we need to go to another break, but when we come back, we have a couple email questions, Twitter questions from folks, and we'll answer a few of those, and we'll talk more about Henk Rogers' incredible ideas and the work that he's doing in research for renewable energy systems, and we're going to talk about the blue ion storage.
All right.
We'll be right back.
Aloha, I'm Kili'i Akina, president of the Grassroot Institute and host on Ehana Kako, a weekly program on the ThinkTech Hawaii broadcast network. Ehana Kako means let's work together. Think of the sad alternative, let's not work together. Here in Hawaii, with all of our diversity and the richness of the people, it's important for us to come together around issues on the basis of what's right and what's good and what's going to serve the common good. And that's what we try to do at Ehana Kako. Every week, we interview movers and shakers, people in government, business, and other sectors of society to talk about how to create together a better government, economy, a better world here in Hawaii that can bless the rest of the world. I thank you for your attention to ThinkTech Hawaii, and we look forward to seeing you every Monday, 2 to 3 p.m. on the ThinkTech Hawaii broadcast network. We're Ehana Kako, and we wish you well. Aloha.
Hi, I'm back with Henk Rogers, and we're discussing energy solutions, renewable energy solutions for Hawaii. And we left off before the break talking about how to use storage, use our electric vehicles and hydrogen vehicles for storage. But you've actually gone ahead and developed a storage solution yourself. So I want to get a chance to talk about the blue ion battery pack, and tell us about it.
Right, so we went through a number of different battery technologies at the ranch, starting with vanadium redox flow batteries, and we had trouble, and they were kind of complicated, using chemicals and so on and so forth. And finally, we narrowed it down to Tesla and Sony.
Mm-hmm.
Now, Tesla, I'm a huge fan of Tesla. I've got one of every one of their cars and got more on order. And
I saw in the Huffington Post that you gave a great shout out to Elon Musk. And
am I allowed to say that on the
yeah,
radio?
tell them what you said. I thought
So
that was
they
pretty
asked
cool.
me, so who's your hero? And I said, my hero is Elon Musk, because he's got planet-sized dreams and planet-sized balls to carry them out with.
Terrific.
So I mean, he is killing it. So, you know, he was my first go-to guy, or Tesla's my first go-to company to do home energy storage. But we examined their batteries, and at the same time, Sony, who I've been friends with Sony, gosh, since they came out with PlayStation. And in fact, if you go through the history, I've been maybe 25 years I've been working with Sony. I've always been friends with the game business became really important for them. And Kazi Rai, who's the president of Sony now, used to run North America game side, PlayStation side, so we're still friends. Anyway, they showed me their battery, and they were the first one to come out with lithium ion, which is actually lithium cobalt, batteries in 1991. And they've been working on it ever since. And they come up with a new chemistry. So the difference between lithium cobalt and the new battery is lithium iron phosphate. Now, lithium iron phosphate and lithium cobalt are different. Lithium cobalt is what's in my Tesla, and it's in your iPhone and in your laptop. And it has a little bit better energy density than the other chemistry. And so it's not as heavy. Okay, so you're not going to find the lithium iron phosphate inside of your phone or inside of your laptop, because weight is such an issue in a car. But if you're talking about a home solution or a stationary solution, one that does not move, the other chemistry is frankly speaking, a better technology. Why? The lithium ion or the lithium cobalt will get hot. If I charge my car in my garage, it turns into a sauna. If I were to have like a bunch of this Tesla batteries in my garage in addition, it would become really, really hot.
Right.
The design of the Tesla battery is made for load shifting, not for peak shaving. They're not that big. They're only 7 kilowatt hours, and basically the average home is like 25 kilowatt hours. So you'd need a whole bunch of those, and you'd have a heat problem. The problem with the lithium cobalt is a heat problem. You need to have a cooling engine going all the time.
Right.
When I'm charging my batteries, the fans go on, trying to get rid of all that heat. The lithium iron phosphate do not get hot
At all?
at all. Well, I can touch them and they're barely warm.
Right.
But there's no cooling system in there at all.
So it reduces the cost of your storage tremendously.
I
Because you're
would
not
say it's
paying
about
for more.
I would
energy.
say, yeah, at the end of the day, you know, Tesla's announced their price point and so on and so forth, but you know, it's going to take them a while to get there.
Well, that's actually
it's a nice talk.
That's actually one of my questions is, how does this compare with Elon Musk's battery?
So again, Elon Musk battery is made for load shifting in California, and our battery is more made for taking people off grid
Okay.
and having a large storage. You want to go with our battery, and then there's no danger of overheating. And so if I'm going to have batteries in my house, I don't want to have a problem with them overheating. That's a picture of the battery, and we put them in server racks. So that what you're looking at here is the storage we have at the ranch. That's 100 kilowatt hours of storage.
And
100 kilowatt hours.
how many square feet more or less is that? Is that the size of a small room?
No, it's one of them is I don't have square feet. I have three
Sorry,
of those
meters.
in my garage.
Okay.
I have three of those
them
in my garage here in Honolulu, so I have 60 kilowatt hours. I
Okay.
mean, 3 of those cases. The answer is it doesn't take nearly as much space as any other battery technology that we've found so far. And it doesn't produce heat. And there's no nasty chemicals involved.
So you could put it in your garage,
It's in my garage.
and there's still room for a car.
Oh, yeah.
A 2-car garage.
Oh, yeah.
That's really important. I want to give our audience an understanding of how they might be able to apply this for their own needs. I know that you have a very large house, say the average 3-bedroom, 4-person house. How much energy would this enable folks to store, and how might they
Well, I
benefit
would
from
say,
it?
you know, an average home, again, is like 25 kilowatt hours. And I overbuilt mine. I don't live in that big of a house. Okay, it's bigger than average, but we have 60 kilowatt hours of storage. And at the time that we built the storage, I didn't have a solar hot water heater.
Okay.
And so I'm still using electricity to heat water, which is a ridiculous thing to do.
I can't believe you're admitting that.
Well, it is a ridiculous thing to do. And because we overbuilt, since then, we've never had a problem. So, but I'm about to build some more stuff onto my house, and I'm going to need more electricity for that. So then I'll build a solar hot water heater to do the right thing.
And I understand that this battery, the blue ion battery, also you can add units onto it so that you can grow with the size of your demand.
Sure. You know, what you see, again, if I could add another server rack and just put more blades in it.
Right.
It's very easy. So it's, how can I say, it's adjustable. How much you want to store, you just add more battery bank.
And this picture, I think, is of your house?
That's my roof on Tantalus, and you can see Honolulu in the background. And, you know, maybe we have a slightly larger array on our house than somebody who's grid-tied.
Mm-hmm.
And it's because we have to live, we're completely dependent on the roof. On a bad day, it still has to produce enough. And it does. In the last few days when we had the really bad days, it may have taken all day, but we got 100% each day.
So if I'm a family of 4 and I'm running Nintendo games and I'm running 54-inch flat screen TVs and a dishwasher, and I'm just trying to get an idea of what people might need, and would this battery storage also be within their budgets, and if not, when would that happen?
So for an average household today, it's still a little expensive. The storage costs about as much as the PV. So if the total cost of the system, half is storage and half is collector. And that will change with time. You know, we're at the very beginning of home storage. And so all of these companies like Tesla and Sony are all going to be competing to bring the price down. And so there are early adopters who are ready to do it right now, like myself. And lots of people in Kahala are ready to do it right now. And there are people who are going to wait for a few years and do it then.
And what your new company is, remind me the name?
It's Blue Planet Energy.
Blue Planet Energy.
And the
And
name
what
of the product is Blue Ion.
Blue Ion. And what you do is you package the system so you provide services as well. Can you explain that?
So the way it works is we work with solar installers like Revolution, and they do the PV side, and we supply the storage side. And so in general, those things go hand in hand. It's no point to have storage without PV.
Right.
And so at the end of the day, we will be supplying batteries to all of the solar installers in Hawaii, so that when people need to get off the grid for whatever reason, they can do that.
And what you've done in Blue Planet Energy is marry your technology skills in software and being able to manage the storage and the interconnection with the Sony battery?
So basically the way Tesla works, like my car, they know at Tesla headquarters everything I'm doing with my car. And so then they can troubleshoot if something's going wrong. They can whatever is going wrong with my car, I can just call them and they know exactly what's the deal. We're doing that same thing for our batteries. So the batteries will talk to our central server, and so we know the battery state at any given time, and we can help you if you are having a problem for some reason. And the thing that we're building now is an app that you can use your phone and find out exactly what the state of your battery is and so on. I can do that with my car right now. I can check to see if it's charged or not.
So you're working on being able to do it with your ranch as well, and your home here on Oahu.
Yeah. Yes.
And that's going to roll out with Blue Planet Energy in the future.
Yes.
Terrific. Well, Hank, I really appreciate you joining us today. Before we wrap up, what I'd love you to do is look into that camera and tell us, oh, I'm sorry, this camera, right
That
over
camera,
here.
the one with the light off? With the
And
Okay.
tell our audience, give them a challenge. Tell them what you'd like people to start doing and focusing on in order to support the kind of sustainability practices you've been implementing.
Right. So what I'd like Hawaii to do is we have a challenge, and the challenge is we need to be 100% renewable by 2045. It's not just a government thing or an electric company thing. It's all of us that need to work together to achieve this. And that's only 30% of the puzzle, or 40% of the puzzle. If we can get to 100%, we need to do transportation. And so I'd love to see people getting out of their cars and into bicycles or into electric cars. Wherever you can find a way to save electricity, that would be a thing that would really help Hawaii in the future. So efficiency, change your light bulbs to LEDs. Gosh, there's just so many things. You can go to our website at blueplanetfoundation.org, I think, .org, and find out all kinds of ways of where you can help Hawaii become energy independent. And that is the future. The future is that Hawaii needs to be energy independent.
Thank you so much for joining us, Hank. I hope you'll come back in the future because there's going to be so much to catch up. You're moving so fast.
I will, promise,
Mahalo.
anytime you call me.
Mahalo. Aloha.